Hello and welcome back to the Cracking Fang YouTube channel. Today we're solving Leetcode 1526, minimum number of increments on subarrays to form a target array. You are given an integer array target, and you have an integer array initial of the same size as target where all the elements are initially 0. In one operation, you can choose any subarray from initial and increment each value by 1. Return the minimum number of operations to form a target array from initial. All right, let's look at a very basic example to get a grip on this problem. So let's think about if we have a target array of 1, 2, 3. Obviously, we know that our initial array is given to us in the same length as our target, except all the elements are 0. Now, what we could do is we could have some sort of naive approach where we just increment each element of our target by however many values are for each corresponding index in the actual target array, right? So for the first one, we increment it by 1. So we get 1. For the second one, we increment it twice. And then we get 3 times for the last one. In total, we get 6 total iterations. But this is the maximum number of iterations it will take and not the minimum. So we need to do better than this. And what you'll notice is that if we just do one at a time, we're actually wasting work because we can increment by 1, which means that we could actually increment everything by 1, and then we don't have to do 2 twice. We would just need to do it by 1. So if we think about this, what if instead we chose to say, okay, well, I'm going to have everything by 1 at first. Now, instead of having to add 2 to the second index, I actually just need to increment it by 1. So we would go increment by 1, the second index, and we can actually increment the third index by 1 as well. So we now have the array 1, 2, 2. And then all we need to do is increment that last piece, and we get 1, 2, 3. And in here, we've actually only used 3 total operations, which is actually kind of the solution here. So you can see that we brought it down from 6 down to 3, which is actually the minimum. And the way that we're going to approach this problem is basically something along these lines. We want to basically just go over our array from left to right. And what we're going to do is we're going to take kind of increments in a a greedy manner. And we're basically just going to fill our target array as we go along. But what we need to do is actually be careful that we don't accidentally increment too much. So for example, when we had the subarray 1, 1, 1, we can no longer consider this element to be incremented. So we need to be careful not to accidentally add too much here. So basically, once an element is actually considered to be done, then we don't want to be incrementing any more to it because we can actually get it over what we want to do in target, and we can only increment our array. We can't then decrement parts of it. So that means that what we need to do is essentially, as we're traversing through our target array, what we want to make sure is that the previous value in our kind of array that we're forming as a part of our result, if the value of that index is actually less than or equal to the current target that we're looking for, then we don't want to be incrementing it or touching it because that means that the current number actually has already been incremented as part of kind of the greedy approach that we did before. So for example, if we were actually looking for, I don't know, let's say 2, 1, 3, obviously we'd increment everything by 1, but we would need to increment this to 2, so we'd have 2, 1, 2, and we want to basically prevent us from over incrementing this middle index when we're considering how many increments we need to do. And the way that we do this by checking the previous element. If that element is actually bigger than it, then that means that we have already done all of the increments for that element as part of kind of just taking greedily for the previous element, if that makes sense. Essentially, we don't want to over increment and overtake elements because essentially we want to take as many increment as many indexes as we can, basically as big of a subarray as we can at each step to minimize the number of steps. And essentially the way that we check that is if the current element that we're looking for to increment if the previous value that we saw in terms of when we're building our kind of solution is actually bigger than it, then we can ignore it, because now that means that we don't want to be touching it anymore. And it's probably already in its correct space. So that is essentially the approach. Let's now go to the code editor and type it up, and hopefully this part about checking the last element will be more clear, and we can actually see it in code and kind of explain how the logic works more in detail. Okay, we're in the code editor. Let's type this up. Remember that we need to keep track of the previous number that we've seen and also the current result. So let's create some variables for those. So we'll say prev equals res equals 0, and there we go. Now we need to basically iterate through each element in target. And what we want to do here, and let's just write this, we're going to say for value in target, we want to check whether the current value is actually greater than the previous value that we've seen. And the reason that you do this is because we want to make sure that we don't actually over increment any particular subarray when it's already done. And we'll look at an example at the end of this to basically show what I mean here. So we're going to say if the current value is actually greater than the previous value, then what we want to do is we want to increment the result by the difference between the current value and the previous number that we've seen. And the reason that we do this difference here is because we basically assume that in the previous value, if its value is actually less than our value, then we haven't incremented the current index enough, and that's why we need to increment it by however many steps are here. And this way we basically just get the correct number of increments. Then obviously we need to update the previous value that we've seen, and we can simply return our result. Let's just make sure this was correct, and we can submit it, and it looks good. Now, before we actually go, let's now look at an example here, which will kind of illustrate this topic. So we'll look at the array of 2, 1, 3. So previous equals 0, results equals to 0. So the current value is going to be 2 as we start iterating. Now what we want to do here is we want to say, okay, we have this 2, and is 2 greater than the previous value? Yes, obviously, because previous is 0. So we want to increment basically the result by 2, because that's the difference between the value and the previous value. And then we want to set the previous value equal to 2. Now we get to 1, and obviously 1 is not greater than 2. And it's not equal to it, which means that we have already done all of the increments that we need to do here, because we can't increment 1 anymore. We can think of, by incrementing this 2, actually what we've done is we've incremented everything by 1, and then technically we've incremented the first index, the second index, and the last index by 1. Obviously you don't see this as we're going along because we're doing it in a greedy manner, but this is essentially the steps that we've done, right? So now what we want to do is, okay, so we've had this step, right? So this was our first, so we had 0, 0, 0. Let's see, yeah, 0, 0, 0. We then went to this step, so, there we go. So we incremented it again. So, we can't increment both at the same time. So actually we've just incremented kind of the first element, right? We incremented everything by 1. Then we had to increment the first element by by another 1, because remember, we can only do a subarray. We can't just pick the elements we want to increment. We have to do a subarray. So that means that this one got incremented. This 1 cannot be incremented again. So that's why we're actually going to skip it on the next time, now that val equals 1. And now we're going to go when val equals 3 for the last one. And we're going to check, okay, is 3 greater than the last value we saw? And last value was 1. Yes, okay, so we basically need to just take the difference between the current value and the previous, and that will tell us basically how many increments we need to do. So we can basically just take the difference. So obviously the difference is 2. So our result here is going to be 4. So basically what we do here, this will transform it from 2, 1, 1 to 2, 1, 2. And then we just perform that last extra increment to get 2, 1, 3. So hopefully that makes a little bit more sense. Obviously the code is pretty straightforward, but the intuition is a little bit confusing to see. Essentially, what we want to do is just make sure that we're not actually over incrementing things, and that's why we're basically tracking the last element that we saw. And since we do it in a greedy manner, we basically take as many increments as we possibly can at each index, and basically we need to check the previous index to make sure that we have incremented correctly. If we have already done all the increments we can do, then we ignore it. Otherwise, we'll actually just take the difference, and that will give us what we need to do for that particular index to make it equal to whatever its corresponding index in target is. Before we go, last thing we need to do is just talk about the time complexity. Obviously, all we're doing is just going over the array from left to right. So this is just going to be big O of n. And for the space complexity, we just have two kind of pointer variables here. So it's going to be big O of 1. So that's how you solve this problem. Pretty difficult. I'd say the code is deceptively simple, but actually figuring out the intuition is a bit trickier. I think given easier test cases, you can probably kind of figure it out. I think the easiest way to understand this is with like a completely monotonically increasing or decreasing sequence, because then you can just increment 1 kind of each time. So you do basically, if you started with this one, you'd have like 1, 1, 1, 1, 1, and then on the next iteration, you just iterate by 1, and then basically you do that. So in this case, it's really simple, but when you have something like this where you need to have peaks and troughs, it becomes more difficult because you can't, you have to do a subarray. You can't just pick and choose elements out of it. So when you have like discontinued elements like this, or disconnected elements like this, it becomes a little bit more tricky, which is why we need to check the previous value to see if we've actually incremented enough. And since we do it in a greedy manner, in the end, we'll actually end up with the kind of correct solution. So hopefully that makes sense. This problem definitely took me a while to kind of visualize. Hopefully I did a decent job of explaining it. If you found the video useful, please leave a like and a comment. It really helps out with the YouTube algorithm. Otherwise, subscribe for more content, and I will see you in the next one. Bye.